Ooh. Problem number 3 out of the textbook for your homework. Guys, pay attention. We're given f of x is equal to x minus 1 times the quantity x minus 1 times the quantity x plus 2i times the quantity x minus 2i. And it says, write the polynomial in standard form and identify the zeros of the function and the x-intercepts of the graph. So now, this is a 4th degree polynomial. So I'm going to write a bunch of stuff over here on the side. So it's a 4th degree polynomial. Okay? And it has 2 real solutions. Okay? So 2 real solutions. And that is going to be x equals 1, because if I take this and set this equal to 0 and solve, I get x equals 1. Now, the imaginary numbers, there's nothing I could do. So a 4th degree polynomial has to have 4 solutions. Now, the real solutions are what we call x-intercepts. That's where it'll cross the x-axis. Now, the 2 real solutions is x equals 1 multiplicity 2. So, does anybody remember what Mr. Adams said about even multiplicities, what that looks like graphically?
They don't cross that.
They don't cross, they just kind of come up next to the axis and touch, right? So, an even multiplicity will either look like this or it'll look like this. It'll touch right at the solution. And in fact, in this one, it's either going to come in from the bottom or it's going to come in from the top, but it'll just barely touch the x-axis. But it touches it, so it's considered an x-intercept. But it won't cross all the way through. I suppose I should do a different color so you guys can think about that. All right? So it's a 4th degree polynomial. It's a positive polynomial. So in reality, it'll probably graphically look something like this. It'll probably come in from the top somewhere, do some crazy thing, and then just barely touch and then leave. Maybe. I don't know what it looks like, but I have a good guess it'll be something like that. 1, 2, 3, 4, 5. Oh, I drew one too many. It'll look more like this. I drew one too many humps. Okay, so that's what it'll look like. It's something like that, maybe. 4th degree polynomials always look like a W sometimes. Or something similar to it. And what else do we need to know? So we know that. So if it has 2 real solutions, then it also has, because it has to have 4 solutions, 2 complex, right? And we know that. How would we get those complex solutions? Set those equal to 0. So that would be x is equal to plus or minus 2i, right? So those are 2 separate complex zeros or solutions. Mr. Adams will say words like zeros or solutions or roots depending on what we're doing, but they all kind of mean the same thing. Most of the time when we deal with real numbers, the x-intercepts are the solutions, but with complex numbers, it's still a solution or 0. It's just not going to cross the x-axis, okay? Because it's not a real number. All right, so now what we need to do is FOIL this bad boy out and see what we get. So I'm going to do the imaginary number first. I've got x and 2i times x minus 2i. I get x squared. That's a 2i. So I've got positive 2ix, negative 2ix. And then negative 2i times positive I is, or 2i is negative 4i squared. So this becomes x squared. These cancel out. And now, what is I squared equal to? Negative 1. What is I squared equal to? I squared always and forever will equal negative 1. So I really have negative 4 times negative 1, which is positive 4. Now I got to multiply these bad boys. X times negative 1 and x times negative 1. I got x squared minus x plus 1. So that's going to equal x squared minus 2x plus 1. So right now, my polynomial is x squared minus 2x plus 1 times the quantity x squared plus 4. What do I do now? Multiply those two. X squared plus 4 times all this stuff. So I've got x to the 4th minus 2x cubed plus x squared, 4x squared minus 8x plus 4. Double check that. I don't have my solution, so will somebody do me a favor and just double check in the back of the book, make sure Mr. Adams didn't make a math error. So I have x to the 4th, is that correct? What's the next term? I'll check in the back of the book, you lazy bums. What's the next one? Negative 2x to the 3rd. Then we have plus 5x squared, yeah? Huh? Plus 5x squared. Then what? Minus 8x plus 4? Okay, good. We did it right. Okay. Were we asked to graph it? Now, here's what I want to do. It doesn't say that we have to write the graph, but it says find the x-intercepts of its graph. Well, that sounds to me like maybe we should graph it. So what I'm going to do is I'm going to enter the graph in here. And it's y equals x to the 4th minus 2x squared plus 5x, oh no, it's 2x cubed plus 5x squared. I wrote down cubed. I better fix that on my paper. All right, 5x squared minus 8x plus 4. Kind of ran out of space there. Is that right? Now my graph is kind of goofy. I gotta zoom in on my graph here. See how my graph looks? It kind of looks like a parabola, but I would assume that if I zoomed out, let me zoom out a little bit. It might just be a parabola. Those are some big numbers. Yeah, it looks like a parabola. So the complex number is so tight. Probably, see this little bump right here? That's probably where it's a little bit of an issue. But yeah, it looks like a parabola. Okay? So, but where does that parabola cross at? Like, where does it touch at? It's not quite a parabola. It looks slightly skewed, doesn't it? Oh, maybe it is a parabola. I don't know. It looks like it. But it touches at 1. And so the x-intercept is at 1, which is the real solution, which is what we said in the beginning, right? We said, I don't know what it'll look like, but it'll probably look something like this. I knew it would come in from the top and go out the top because it's a 4th degree or even degree polynomial. I knew that the real solution was a multiplicity of 2, which means it's going to touch at 1. I knew that it had 2 complex zeros, and so those 2 complex zeros were not x-intercepts, and everything else is just based on the graph, okay? Any questions on any of those things?